This is a set theory question. Okay. So in a class of 100 students, there are 30 students who neither like romantic movies nor comedies. The number of students who like romantic movies is twice the number of students who like comedy movies. The number of students who like both romantic movies and comedy movies is 20. Okay. So there are total 100 students in this class. Out of this, 30 students neither like romantic movies nor comedy. Okay. So let's understand this game here. Okay. So what is this set? If you want to draw it, let me draw the Venn diagram. We want to draw a set, it will look something like this. Let's say this is the universal set consisting of 100 students. Now there's a set of students who like this thing, what do you say, romantic movies, and let's say there is some number of students who like this. So, okay, so total out of 100 students, right? Now see, let's understand the game here. What they are saying is 30 students neither like romantic movies nor comedy movies. So that means this 30 students are here. Okay. So it's like saying number of R complement intersection, what is that? Romantic and comedy, right? C complement. The complement we write by the term C is 30. Okay. What is the benefit of this? This is technically, if you remember, by De Morgan's law. De Morgan's law. This is coming in probability also. This is coming in set theory also. This is coming in what do you say? Even in your discrete maths for this thing, propositional logic. There also it pops up. Okay, this is a famous law. So De Morgan's law says that see, for probability it will be based on probability. For here it will be based on what? Number of R complement intersection C complement is always equals to number of R union C the whole complement. You can write like this. Now, what is this number of R union C the whole complement? Now, number of R union C the whole complement is always total elements in the universe minus R union C, number of elements in R union C. So, total of elements in the universe, that is number of students in the class is 100 minus R union C, I don't know. So, but this value is known. What is this value? 30. So from that, you can come to a conclusion that number of R union C is technically what? 70. So this is R, this is C. Okay, one thing. One more thing, the shaded region. This is representing what? Number of R intersection C. That is students who like comedy as well as romantic movies. For them, it is given in the question as, what is that? 20. Okay. Now, if you remember the union formula for number of elements, it will be like this. Number of R union C will be number of romantic movies plus number of comedy movies minus number of romantic intersection comedy. So the only thing I don't know is these two entities. And I think so there's a connection for these two entities also. They are saying that number of students who like romantic movies is twice that of the number of students who like comedy movies. That is, they are saying that number of romantic people or students who like romantic movies is twice that of number of students who like comedy movies. So this is twice. So based on this, you can substitute and find the answer here. So this we already found out as 70. Number of romantic, I'm replacing that by number of comedy plus number of comedy minus intersection we already found out as 20. It's given 20, not found. It's already given in the data. So let's take this over here. So 90 is equals to 2 times of number of n stands for number of comedy. Okay, the number of 2 times plus 1 is 3. 3 times of number of comedy. So number of comedy works out to be 30. If number of comedy is 30, then number of romantic is what? Twice of that is 60. That's it. Based on this, so we found out every element here. Now, what is the question asked there? Let's see. How many students in the class like just romantic movies? So we found out that the answer is 60. So answer is this option. Option C is the answer. That's it. So learn how to manage set theory. That's it. It's a very simple question. I hope this is understood by everyone. Is it clear? Hello? Are you clear? Shiva Subramanian, Maharaja, Vaishnavi, Yuvraj, Nisha, Manigandan, Swati, Jessica, I hope you're clear. Any doubts you can ask me? Okay, so this, why this is like this is because based on number of elements. Okay, so this is the concept from where we work this out. Okay, so you can see that's the benefit of De Morgan's law. De Morgan's law can be applicable for probability issues, even for number of set theory, number of elements. You can use De Morgan's law in propositional logic. Okay, so I'm showing you this. Okay, so that's one thing. Okay, let's go for next problem. Okay, I'm going to show you this question. You have to answer me from your side. Okay. Now tell me how many rectangles are there in this figure. You have to identify number of rectangles here. Even squares you have to consider as a rectangle. Okay. Square is a special case of rectangle. So please tell me how many rectangles are there in the figure. Please try to answer it. Shiva Subramani is saying 8. What about others? Yuvraj is counting 10. Maharaj is counting 10. Nisha is saying there is 10. What about others? You can also attempt. Not only the students. Okay, so yeah, most of you are coming out as 10. I think so. The answer is 10. Yeah. So let's check it out. Okay, I will draw it with different colors. So let's start with the most basic one. So this is one, right? One rectangle, second rectangle, third rectangle, and fourth rectangle. So that is covered. Now let's go for different color. This is one rectangle, like you can see this red color. This is your fifth. This is your sixth. Then what? Yeah. This is your seventh. And then this is your eighth. Okay. Then this whole thing, this whole figure is also a rectangle, right? So this is your what? Ninth one. And the last one is your entire outer rectangle, this one. Okay. If I want, I can take a different color for that. Yeah, blue is already there, right? So the black one. So this one. So like that, there is 10 rectangles. So correct answer is option 10. Question 9. Is it clear? Vaishnavi and Shiva Subramanian? Understood the count why is 10? Others also clear why we got the 10? Okay, so you have to be careful. This question I've been asked a lot. In some gate papers, I saw it as how many triangles are there, like that. Okay, that was a bit tough here. So you have to be very careful here. Okay, so it's actually the answer is 10. Yeah, correct. So most of you got it. This counting error always happens here. Okay, so you have to be very careful here. Remember, luckily I can use my pen to draw this, but in gate paper you have to count it out properly. Okay, so better you try to roughly draw it on a piece of paper, and from there you come to a idea there. Okay. Okay, then. So that's it. Let's go for next question. This is a geometry related question. So sometimes the geometry questions are a bit challenging. Okay. So you have to be very careful here. Not very tough, but you have to have a good logic over it. Okay. So let's understand the game here. Okay, so this is a parallelogram. PQRS is a parallelogram where one of the side is 7 centimeter. Then height from P to the base is given as 4 centimeter, and PV, which is again a perpendicular to another side of the parallelogram RS, that is given as 5 centimeter. I have to find the length of RS. Okay. So how to work out this? So let me draw a construction here. Let me draw a line like this. Sorry, let me take a different color. Let me draw a line like this. Okay. So I'm dividing parallelogram into two triangles here. Okay. So one is what triangle? Triangle PQR and triangle PRS. So we have two triangles here. Now, if you understand basics of parallelogram, I can first of all conclude that area of triangle PQR is equal to area of triangle PRS. Why I can do that? Because in parallelogram, you get half area here, right? The area gets equally divided. Okay. PQR is this segment and PRS is this segment. Okay. So these triangles are always going to be equal to each other. Okay. Now, what is the area of triangle PQR? We have height from height of the triangle and base of the triangle. So I can say that half into base, that height is what? I think so height is 4 and base is 7. So half of 4 into 7 is the area of triangle. What is the triangle of PRS? Height is given to us. What is height? 5 centimeter, and base I don't know. 5 into base RS I'm going to take. Half gets cancelled out. So RS will be equal to what, right? 4 into 7 divided by 5, which works out to be 28 divided by 5. Let's see such an option exists. Yeah, 28 divided by 5, option B is the answer. Is it understood how I develop this idea? To just understand, take a diagonal PR and remember, in a parallelogram, whatever diagonal you take, diagonal divides the area into two equal parts. And from there, you can come to a conclusion. Is it clear how simply I solve this problem? The critical part is imagining the diagonal here. Once you get the diagonal, then the process is very easy. Students struggle at getting that diagonal. Is it clear? Understood, guys? Huh? Anyone has any doubt, you can ask me. Okay, then let's go. Others are also clear, na? Yuvraj, Swadi, Abhinaya, Bhavdarni, Swadi. Understood, na? Everyone, okay, good. Okay. Yeah, you can even solve this by similarity criteria. Like you can say that similarity criteria, like you can take the ratio of the segments. Okay, you can say that PQR and PRS are similar to each other. Based on that, ratio of their base will be equal to ratio of the heights. Same thing. It works out as same thing. Yeah. So Shiva Subramanian, you can use even similarity ideas also. You can say like this: PT multiplied by QR, that product will be equal to what is the PV multiplied by RS. That's one way to approach it. Or you can say that the ratio of PT divided by what is a PV. That similarity law. Just 1 minute. Similarity law actually doesn't work for this thing. Height, Shiva Subramanian, the only problem here is similarity law, you cannot include the height. Shiva Subramanian, please understand, do not include height in the similarity law. If you take the length ratio, that's okay. That is the side ratios you can take it, but you cannot take height ratios unless and until it's a common height. If it's a common height, then you can take it. Otherwise, you cannot take it. Okay. Please be careful here. Please don't take the height ratio here. Otherwise, you will completely because you can see here. If you see the area idea, na, in that area idea, you can see something weird happening here. So what is the height here? Height is PT and QR, right? So PT into QR is equal to what, right? What is happening here? The half, if I cancel it out, PV into RS. PV into RS. So if I take PT by what is that PV, I am getting RS divided by QR. So it's actually kind of inversely proportional. PT is inversely proportional to QR. And PV is inversely proportional to RS. So because of that inverse proportionality, you can guess out from the triangle itself. As the base length is larger, height is smaller. As the base length is smaller, height is larger. Where is the figure? Yeah. We can see this is the larger base, but the height is smaller here. This is the smaller base, so height is larger here. So height you cannot take it because height is not part of a common height. Like what I meant by common height is, let's say I'm having a triangle like this. And if I draw height like this, then this is a common height idea. There you can take the length height ratios as part of the length ratio. This is drawing height in two different directions. That's why I cannot take it the height ratio. Understood, Shivsurman, what I'm trying to say here, why similarities with height is not allowed. Other similarities are allowed. Clear? Understood what I'm trying to say? Okay. I hope you understood that. Okay, let's come to the next problem. Okay, this is a reasoning kind of problem. Okay. The line of symmetry is defined as a line that divides a figure into two parts in a way such that each part is a mirror image of the other. About that line. Okay, so the given figure consists of 16 squares arranged as shown. In addition to the 3 black squares, what is the minimum number of squares that must be colored such that both PQ and MN forms lines of equal symmetry? Okay, so I can draw it here itself. Okay, let's try it out. Now, first, let's start with this diagonal segment. This diagonal segment, this is already symmetrical, right? This black and this black. That is this one. And this one is already symmetrical. So the only symmetrical I need is this one. If I make it black, so now you can see something happening here. You can see that it is almost similar to, or that is with respect to MN segment, that is the diagonal segment or diagonal line, you can say that this is similarity. Okay, please bear with me. Okay. So you what? So I draw one square. Okay, please know that. So one square is drawn. And anything else I need? Yeah. Now I need similarity not only with MN, I also need similarity with the vertical line PQ. Is that similarity? Okay, this is there, this is there. So here also I have to draw. Then only it will become similar. And one more here also I have to draw. So now I have introduced 2 more squares here. Okay, so total 2 squares I have introduced for making similarity with PQ. Now PQ is similar, but what about MN? Let's say MN is similar or not. MN similarity issue is again popping up there. This new, because I colored this new, I have to again color this as well. Okay. So one here. So you can see that it is similar, and one again here. Okay. So 2 more squares I have colored it. So now tell me, are all squares are similarity everywhere now? We can see that MN this is similar, this is similar, this is similar, and this is similar. So MN is okay. What about PQ? This is similar, this is similar, this is similar, this is similar. So now everything is over. So totally how many squares did I take? 5 squares. 1 plus 2 plus 2, that is 5. The total 5 squares are needed for similarity for both, that is PQ as well as MN. Understood the game? Is it clear how I come to the conclusion of 5 squares? I started with the easiest one and then I manipulated accordingly. Hello, are you understanding? Everyone, are you clear? Or do I need to repeat it again? Okay then. Let's go for next question. Okay. Now to construct a wall, sand and cement are mixed in the ratios of 3:1. The cost of sand and that of cement are in the ratio of 1:2. Okay. If the total cost of sand and cement to construct the wall is 1,000 rupees, then what is the cost of cement used? Okay, so how to find this, right? So this is the concept of ratios here. Okay, sometimes ratios have been asked as part of this thing, but it's a very rare thing to ask. Okay, so that's how I quickly do the ratio. First of all, sand and cement are mixed in the ratio of 3:1, right? So if I say sand, I can say that sand is to cement. The quantity is 3:1. So I can say that sand is 3 units quantity wise. Or you can write like this. Sorry. Quantity of sand is how much units? 3 units. And quantity of what you say cement is 1 unit. One more thing, the ratio is given. And that second ratio is actually what, right? Sorry. The cost of sand and cement is 1:2. So sand and cement cost. So this is the ratio of cost, okay? And they're saying it is 1:2. So I can say that cost of sand is 1 unit and cost of cement is 2 units. Now, 3 units of sand, if I buy it, sorry, cost of sand is 1 minute. Okay, yeah, correct. The cost of sand is in the ratio of, so cost of sand is, they are saying that if I buy 1 unit for that same price, I can buy, okay. So what is the expenditure on sand here? Expenditure on sand will be quantity 3 into what is the cost? 1. So 3 units will be the expenditure. Expenditure on cement will be what, right? 1 into 2, that is 2 units. Now, total expenditure will be what, right? Total expenditure will be 3 plus 2, that is 5 units. Now, this 5 units multiplied by some quantity must be equal to 1,000, right? Why? They are saying that the total cost of expenditure I am getting is 1,000 rupees. So what is the X value here? So X value is coming out to be, what is that? 1,000 divided by 5, that is 200 rupees. Okay. And see, 5 unit is based on this particular entity. I am not saying that the exact unit of sand is 3 and exact unit quantity of cement is 1. Let's say the quantity can be like 9:3. 9 units of sand and 3 units of cement, or 9 kilos of sand and 3 kilos of cement. So there are a lot of different ways which can answer. So the X value I'm getting is 200 units. Okay. Clear? So from this, what can I say? X quantity is 3. So now what is the question asked for me? Just 1 minute. Where is that question? Just 1 minute. So I want the cost of cement used. Okay. So how much is the cost of cement? So tell me, cost of cement is how much units, right? 2 units. You can call this X value as 1 unit price. This X is the price of 1 unit or expenditure of 1 unit. You can call this X value is expenditure of what? Expenditure of 1 unit. So if you assume that, from there, what can I conclude? So 1 unit value is 200. So what is the expenditure of sand? 3 units. So 3 into 200, which works out to be 600. What is the expenditure of cement? 2 units. So 2 into 200, that is 400. So what is our requirement? Our requirement is to find cement. So what is the cement value? Cement value is coming out as 400 units. The answer is option A. Option A is the answer. Understood how I manage this out? So ratios I manage like this. So by unit ID, I can manage it as the benefit I get with the unit ID is I don't have to wait for any complex values. I can simplify this out by this idea. Is this idea understood, or do I need to explain it again? Hello, students. Do you want the explanation again, or is this okay? Nisha, okay. What about others? Shiv Subramanian, Vaishnav, Swadi. Oh, sorry, Vaishnavi. My mistake. Jessica, Adarsh, Bhavdharmi, Manikandan, Balaji, Shanmuga, Abhinaya. I hope you all are clear. So this is how yeah, Swati, can you raise hand? I can so that we can talk if your mic is available. Okay, Swati, what's the issue? What did you not understood?
Sir, I don't understand how the unit and the cost was integrated into the equation.
Okay, just don't cut off. Let me tell you what to do. See, the cost is so, sorry, quantity is given as 3:1, right?
Okay.
So I can say that it's some 3 units. It's a multiple of three value. Whatever is the quantity going to come, it's some multiple of three, right?
Okay.
And whatever quantity of cement is going to come, it is some multiple of one. Such that the ratio comes out to be 3:1, right?
Yes.
It can have multiple values like for 12 divided by 14, 15 divided by 5, like that. You can create a lot of conditions here. So instead of going for this bigger values, I'm saying that the quantity is 3 units. I'm just assuming the quantity is 3 units.
No, I understood that.
Yeah.
But the cost, is it per unit or how is it given? Because if the cost is per unit, then
No,
shouldn't
no,
the
no.
total expenditure?
Let's understand. See, when I say unit for one ratio, that same unit doesn't exist for this another ratio.
Okay.
Like, let me give you are given two ratios, right? 3:1
Mm.
and 1:2. Are they having the same multiples?
No.
They can have, they cannot have, right? I don't know. Are you getting the point here?
Okay.
Okay. The problem is if I take the multiples values, that is by saying that multiples of first ratio is x and the multiples of second ratio is y, it creates its own complication. Let me show you what's the conventional way of doing. Since sand to cement quantity ratio is quantity of sand, I can call it as 3x, some multiple x, and quantity of cement, I can say it as 1x. Am I right?
Okay.
Quantity of, sorry, no, quantity, like cost. Let's go for next cost. Cost ratio is 2:1. Na? So the cost of sand is what, right?
So the
2y.
right, your
2y.
writing is not clear. It's above the board. Can you scroll up or
Is it not
hello?
clear? Yeah,
No,
it's
no.
clear. It's clear.
The screen, I think you have to scroll up. It's not visible in my screen.
My screen is okay.
The first sentence of cost, it's not visible in my screen. From the second one, it's clear.
Okay, let me do one thing. Let me write it down if that is okay. Is this clear now?
Yeah, yeah, it's clear.
Okay. Cost of what cement is, what did I say? It is the no, cost of sand is 3x, quantity of sand is 3x, and the quantity of cement is 2x, right?
Okay.
Cost of cement is working out as, if I'm taking different multiple, cement is, cement, alla, sand. First is sand, na? Sand, and second is cement. That is working as Y. Okay. Now tell
Mm.
me what is the expenditure?
1,000.
Expenditure is always cost, quantity multiplied by cost, right?
Yes.
If I'm buying apples, I'm buying 10 kilograms of apple, and per kilogram cost of apple is 50 rupees. Then how many? What is my expenditure on that? Expenditure is always going to be quantity multiplied by the cost.
Oh,
Am I right?
yes. Yes, yes.
So expenditure on, let's say, sand. What is that going to be? 3x into 2y. Am I right?
Yes.
Expenditure on cement is going to be what, right? 2x into y.
Yeah, yes.
Yeah. So just add it up. This is what, 6xy. 6 6. I just wrote down. No, sorry. I made a mistake. 1 is to 2, na? So 2 is here. My mistake. Cost of sand is y, and cost of cement is 2y. My mistake. Please correct it. Okay. This is 2y, and this works out to be 3xy, and this works out to be 3 is to, I think so. Somewhere is wrong. Yeah. This is also wrong. Sorry.
Quantity is 3:1.
No. Cement is wrong. Cement is C. 3 is to 1 ratio, 1 is to 2 ratio. I took 3 is to 2 ratio. I made a mistake there. Sand is three quantities, cement is 1 quantity, right?
Yes.
To 1. Okay. And cost is 1 is to 2. So I made the big blunder. I changed the ratios. Okay. That's why I'm correcting it out. So 3x into y, that is okay. This will be 2x into, not 2x, x into 2y. Am I right? Hello? Swati? You say mic off. Swati, you can unmute yourself. Hello? Swati, I think so. You have muted your mic. Yeah. Can you hear me now?
Yes, sir.
Okay. Don't mute it. Just keep the mic open. Okay.
Mm.
X into 2y, what is going to come as 2xy, right? So if I add this expenditure, what will I get? They are saying that the
Next one
cost
will
of
be
sand
20.
is 1,000 rupees. Cement and sand included, right?
Yeah, so X will be 20.
So it
20.
is coming out as
200.
5xy is equal to 1,000. So the xy product I'm getting is what, right?
200.
200. What is this xy product?
Cost
XY is
per
the
quantity.
XY you can say it as it's a multiple of sand. Sorry, expenditure of sand and expenditure of cement. You can say that it's a multiple of expenditure of sand and expenditure of cement. Now, if I multiply this XY value in the sand, what will I get? 3 into 200. What is the answer? 600. And expenditure of cement, if I multiply 2 into 200, what will I get? 400.
400.
That's what I did now in the other case. But instead of taking these X and Y variables, I did it with the concept known as unit idea. Understood the
Okay.
game?
Yeah, I understood this approach. I didn't understand the last one. Okay.
No, last approach, instead of X and Y, calling that as X and Y, I call that as unit, some multiple.
So did you consider the cost as per so cost per quantity, or how did
Cost
you
is always
consider?
going to be quantity. Na? The cost always they are going to mention per quantity. Otherwise, how can I compare it?
No, I didn't understand if the cost was for the whole 3x units or for
It's always
per
per.
unit it was
It's per.
some
You
y and we have to multiply it by 3.
see if it's a total cost of sand, then I don't have to multiply by the quantity, right?
Okay.
So that doesn't come as a cost. That is actually represented as expenditure.
Okay, sir. Okay,
Okay.
I got it. Yeah.
Otherwise, it creates an own issue because if I take a different ratio, if I take expenditure, that's the reason why we don't prefer expenditure ratios. Expenditure is something we use to formulate an equation, but we never prefer to generate a ratio of that.
Okay.
But expenditure, different situation has a different context also. So there we sometimes take a ratio if you're talking about your savings and expenditure. That's a different game. Here, expenditure I'm talking about what I'm spending. That's it.
Okay,
Okay.
sir. I understood. Okay.
Yeah.
Thank you.
Okay. All others, I hope you're clear. Okay. So when you have a doubt, if your mics are working now, you can like that just raise your hand. We can then frankly talk here. Okay. So this is one way. So we've solved it out. Let's go for next problem. I think so this one. Yeah. Now this is something coming from maths. What the question they are saying is the coefficient of x raised to 4 in the polynomial x minus 1 the whole cube into x minus 2 the whole cube. Now guys, there is a way of handling this as a multinomial, but I don't prefer that idea. I'm going to do it in a regular way. Okay, so let's deal with this. So what is that? X minus 1 the whole cube into x minus 2 the whole cube. Some people may think that why can't I do like this? X minus 1 into x minus 2. I can take q as common, right? If I take that, x minus 1 into x minus 2 is technically working out as x square minus 3x plus 2 the whole cube. The problem is this is not trinomial function. That is, there are three terms here. Formula for trinomial is a very complex one, so I don't prefer it. So this approach, because it's coming out as trinomial, I'm stopping there. I'm not going to do like that. So what's the other approach? Let's go for the conventional way, and from there we can guess it out. Okay. So let's expand x minus 1 the whole cube as complete expansion. So what is that? X cube minus 3x square plus 3x minus 1. This is the expansion. A minus b the whole cube. I'm doing a minus b the whole cube here. Okay. What about the other case? X cube minus 3 into x square into 2. So 3 into 2 is minus 6. So 6x square plus 3 into x into 2 square. What is 2 square? 4. 4 into 3, 12. So 12x minus 3 day cube. What is, 2 day cube. That is 8. Okay. Once you get this, from there, I'm not going to multiply the entire thing. I'm only interested in finding the coefficient of x raised to 4. How to do that? See, if I multiply x cube with the x term, this x cube with this x term, I will get one coefficient. So what are the coefficient here? 1, and here the coefficient is plus 12. So 1 multiplied by plus 12 is I'm going to get a 12. That's one way of getting x raised to 4. What's another way of getting x raised to 4? If this x cube is multiplied with this x, what are the coefficient here? 1, and here the coefficient is 3. So 1 multiplied by 3, I'm going to get 3. So add all the coefficients. Next, what is the next coefficient where x raised to 4 can pop up? This one. 3x square and minus 6x square. So minus the coefficients of 3x square and minus 6x square is what, right? What is that? Minus 3 into minus 6. So minus 3 into minus 6 is plus 18. Then is there any other way of getting x raised to 4? Just tell me. These are the only ways of getting x raised to 4, right? Is there any other way? Okay. Now just add it up. So 18 plus 12 works out to be 30. 30 plus 3, 33. That's it. Answer is over. Option A, 33. Understood? So this is how I approach. Rather than doing, you can even do the entire multiplication, but again, it's a very going to be a very horrible equation or very lengthy equation. So why are you wasting time on it? I am only interested in the coefficient of x raised to 4. Just see all the possibilities of x raised to 4, and from there come to the conclusion. Understood? This is what I prefer rather than going for trinomial expansion. Is this clear? Any doubt here? Students, are you clear with this? Nisha clear, Shiva Subramanian clear. What about others? Swadi, Balaji, Manikandan, Abhinaya, Adarsh, Adrika. Are you clear? Yuvraj, are you clear? Okay. I hope everyone is clear. Let's go for next problem. Okay, so this is a very logical problem. Let's see. Ankita has to climb 5 stairs starting at the ground while respecting the following rules. At any stage, Ankita can move either 1 or 2 stairs up. At any stage, Ankita cannot move to a lower step. So she can only move up, she cannot come back. Let Fn denote the number of possible ways in which Ankita can reach an nth stair. So if F1 stands for if there is only one stair, what are the possible ways of getting one stair? One way. F2 means 2 stairs are there. Then how many ways of getting to 2 stairs? 2 ways are there. Okay, what about F3? There are how many ways? 3 ways of getting to the top of the third stair. So like that, for F5, what are the possible ways? Let me explain these ways which are given to you already. So F1 means there is only one stair. Sorry, F1 means there is only one stair. Let's say this is the stair. So F1 means there is only one way to get that. She has to climb one step. Now let's say there are 2 stairs. Okay. So F2, what is 2? Let me explain it. She can climb one stair and then one stair. That is one way. Or she can directly climb 2 stairs. She is also allowed to climb 2 stairs. Okay. So that's why it is called 2 ways. What about F3? Let me show you. If I introduce what is it? One more stair here. So what are the possibilities here? Let's work out the logic. First case, she can climb each stair one by one. So that is one way. Then she can do one thing. She can directly jump 2 stairs. Okay. So 1, 2. Sorry. My mistake. She's walking from the ground. I forgot the ground value. Okay. Ground. She can climb from 1 like this. Sorry, my correction. Let me correct it. She can directly jump from the ground to the second stair and then go to the third stair. So that is second way. Then another way is she can jump to this stair and directly jump to the third stair. That is the third way. That's how the value 3 came into picture. F3 value is coming out as 3. So similarly, you have to find the value of 5 stairs. Okay, so let me show you how to manage 5 stairs. So let's draw 2 more stairs, 4th and 5th here. Okay, so we have to be careful how to manage this. So ground in the 1, then 1, then 1, then 1, then 1. That is one way. Okay, next. Ground in is she is jumping 2, again jumping 2, and jumping 1. That's one way. Next, she is jumping to 1 stair, then 2 stair, then 2 stair. That is one way. Any other way here? She is from, let me take a different color now, because otherwise you'll get confused. Now she is jumping 1 stair, 2 stair, then 1 stair. Another way. She is jumping one stair, one stair, one stair, and then two stair. Any other way? Yeah. She is jumping two stair, one stair, and then two stair. Okay. So like that, you have to work out all the possibilities here. Uh, so let's write one by one. So first case is what? One, one, one. Then what? Uh, one, two, 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 one, and then two, one, two. Okay. Then this is two twos, two twos, two twos. Okay. Then one, 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 and then two. One, one, two, one. One, two, one, one. How to understand is when you add all these values, you should get five. Okay. So two, one, one, one. Okay. Is there any other way? Two, two, one we already discussed. One, one, one is already discussed. Then one, two, three, one, two, three, one, two, three. Double two, double two. Every case is done. Then yeah, this is pretty much the cases. Okay, triple one two is already discussed. Yeah, all the cases are over. So total, how many cases are there? Count it. 1, 2, 3, 4, 5, 6, 7, 8, 8 cases. So F7, F5 value will be what? 8. So how did I conclude is, see, I was drawing it, then the drawing started to become horrible, right? So that's why then I went to the number idea. So when I went to the number idea, when I wrote down some of the cases which I generated, I realized that instead of thinking in each stair and drawing the figure, let's think like this, that the sum of the bracket should always come out to be 5. So like that, what all possibilities you can generate. And from there, you can find out the answer. So what is the correct answer? F5, which is 8. Understood now? The answer is option A, 8. Is it clear how we solved it out? And out? Do I need to repeat this again? Okay. So this is pretty much clear. Let's go for next case. Okay, this you try to answer on your own. This is a verbal question. So this is what is that? Thinking the sentence in different persons or in direct to indirect speech. Okay, English language, direct to indirect speech. So direct speech is given like this. Rafi told Mary that I am thinking of watching a film this weekend. Then the following reports the above statement in indirect speech. So Rafi told Mary that he dash of watching a film that weekend. What is the correct term? Can you try to answer this? In indirect speech, for the dash, what should I come? Should I go? Rafi told Mary that he thought of watching a film that weekend. He is thinking of watching the film that weekend. He am thinking of watching the film that weekend, or he was thinking of watching the film that weekend. Which is the correct answer? Please try to answer this. Correct answer is not A. Correct answer is see. I am thinking of watching a film that weekend. Okay. Sorry, this weekend. So when I refer to that, yeah, Vaishnavi, you are correct. The correct answer is Rafi told Mary that he was thinking of watching a film that weekend. He thought cannot be a proper answer. See, understand how the sentence is formulated here. I am thinking of watching a film that I'm possibly trying, I'm going to watch a film. That's what is meant here. When you say he thought of watching, means he's like, he actually like, I thought of something. Like you are saying like that. Okay. That's not a proper way of sentence. He is thinking cannot be said because of the tense issues. Because of that weekend, whenever you're referring, you're actually going for the past tense ideas. So that's why I have to go for was thinking. Understood? Shiva Subramanian, Nisha, Yuvraj, Maharaja. Why option D is the perfect answer? Do I need to repeat again? Yuvraj, Maharaja, okay. Shiva Subramanian, understood, na? Okay, okay. So correct answer is option D. See, in this kind of filling the blanks, now always what happens is two options will be confusing. Out of the four options, two options will be confusing. So then check the tense and how it works. From there, you can come to a certain conclusion. Okay. Next. Can I answer this? Please try to. Please try to answer this. Permit dash, enforce, relax. Which option is the answer? Okay, everyone didn't get the context of the question. They are not asking for similar meaning. Just see the logic there. Enforce, relax are actually, let's understand the concept of rules. Enforcing the rules and relaxing the rules is different meaning, right? They're actually opposite of each other. Enforcing means I'm completely checking out the rules, and if I'm relaxing the rules, that's a different thing. So if so, enforce and relax here are in the opposite context. So if that is the opposite context, then you permit also you have to allow in the opposite context. Okay. So whenever you see such thing, see the given condition. Are they same meaning? That is, are they synonyms or anonyms? If they are synonyms, then go for the same meaning. If they are anonyms, then go for the opposite meaning. This is anonym. So correct answer is those people who answered B. Swadi, Manikandan, Balaji, you are right. The answer is option B, forbid. Permit, you have to take the opposite meaning of permit, that is forbid. Understood? Others you got wrong. Vivaraj, Vaishnavi, Nisha, Shiva Subramanian, I hope you are clear with this. Why I am taking option B as the answer. Because the conditions given there are actually opposite meaning, not same meaning. See, don't think that this is always same meaning. Sometimes this is also opposite meaning. You have to understand what rules are given in the data. Okay, according to come to the conclusion. Okay, let's go for next. Yeah, okay, good. Next. What it's saying is, a recent tobacco survey shows that 65% of the tobacco users were advised to stop consuming tobacco. Okay, so out of 100 people, 65 people were advised to stop consuming. The survey also shows that 3 out of 10 tobacco users attempted to stop the using tobacco. Based only on the information in the above passage, which of the following options can be legally inferred with certainty? Okay. They are saying that majority of the tobacco users who were advised to stop consuming tobacco made an attempt to do so. Majority of the tobacco users who were advised to stop consuming tobacco did not attempt to do so. Approximately 30% of the tobacco users successfully stopped consuming tobacco. Approximately 65% of tobacco users successfully stopped consuming tobacco. So obviously 65% is not correct. because you can see that 3 out of 10 tobacco users only tried to stop. Even option C is also not correct. See, they attempted to stop, and the option C is claiming that they completely stopped using tobacco. No, they made an attempt to stop. There's a difference between attempt to stop and completely stopping. Okay, so that's why option C is not right. So the answer is lying either in option A or option B. Okay, now let's analyze the data from percentage. So 65 percentage out there. When you say 65 percentage, that is, you can imagine the ratio as 65 by 100. That's what a percentage means. Let's say in that town, let's say 100 people are there. How many were advised for consuming tobacco? 600, 65. How many were not advised? That they didn't got this advice. They were, so 100 minus 65, that works out to be 35. So 35 didn't get the advice. Okay. Now, what another data they are saying is, out of this 100 students, 3 out of 10. 3 out of 10 means out of 100 it is going to be 10. 10 people attempted to stop. Attempted how many people? 30 people. Out of 10, 3. So out of 100 is 30. Did not attempt. That is what? 70 people did not attempt. Now, from advised, if I say 30 people all were advised and they come from the set of advice, if 30 divided by 65, what is the percentage value of 30 divided by 65? Just try to work it out. Okay, you can see that 30 divided by 65. What is 65 and a half? 65 and a half is actually 32.5. Right? 65 and a half is 32.5. You can see that your 30 value is less than 32.5. So what I can guess is this is less than 50 percentage. If I solve it and find it out, it will be less than 50 percentage. Okay, if you want, this is 13. 5, say 5 13s are, this is 5 20s are. So 13 to 20 is 600 divided by 13. You can calculate out. 13 fours are, what is that? 52, 80, then 65, 46 point something value will come. Okay, so you can see that it's less than 50 percentage. So the only conclusion I can draw out here is the option B, I think so. Majority of the tobacco users who were advised to stop consuming tobacco did not attempt to do so. That is, majority means it has to be above 50 percentage. Since it is less than 50 percentage, majority didn't attempt to do so, even after getting the advice. That's what I can conclude here. Okay. They made an attempt to do so. I am not sure. Option A is not the correct answer because they have to be, value should have been more than 50 percentage, but I'm getting less than 50 percentage. So are you understanding? So why 50 I focus on? Because less than and more than majority. When I say majority, it has to be more than 50 percentage. It has to always be more than half. That's what I call as majority in a group. Okay, so that's how I came to the conclusion option B. Is it clear? Students, please respond if you're clear. Okay, let's do one more problem, last problem, and then we can wind up. Okay. Yeah. Okay, so they're asking digits in the unit place for the product 399 into 7 raised to 1000. Okay. Now, very carefully listen here. This is a game of power cycle. So I want unit place value of 3 raised to 999 and multiplied by 7 raised to 1000. First of all, let's do one thing. Let's write like this. 3 into, sorry. 3 into 999 into 7 raised to 999 plus 1. I'll show you why I'm writing like this. Okay, I can write like this. 7 raised to 1000, I'm writing it as 999 plus 1, right? So what does it become? Now, these two portions can be taken common. This can be written as 3 into 7 raised to 999 into 7. Okay, so this is what working out to be 21 raised to triple nine into 7. Okay, now you might be asking, sir, we have converted a different TDS value. Okay, not a TDS value. It's very easy to manage. I'll show you how to manage this. See, 21. 21 day unit place is watering 1. 21 day unit place is watering 1. If I take square of 21, I will get 441. If I take cube of 21, you can find it in your calculator. What is cube of 221? Check it out in a calculator. 21 into 21 into 21. It is 9261 something. I'm not interested in the value of it. What I'm interested is in the unit place. You can see that you raise any power of 21. The unit place is always going to be 1. Irrespective of all the other values, unit place is always going to 1. So 21 raised to 999 is also going to have a unit place of 1. Understood? This is the reason why I converted like this. Okay, so this is how I manage it out. I could have gone for 3 and 7 also, but since I saw that 999 and 1000 this power are very near to each other, I tried to combine. And when I combined, I got a very beautiful number 21. 21, because the unit place is 1, the unit any power you raise it, the unit place is always going to be 1. Then there is an extra 7 outside, right? 1 into 7, when I multiply, the unit place is going to be 7. That's it. Answer is over. So answer to this question is 7. Is that option available? Yeah, option A. So this is how we quickly find it out. Is it clear?